Welcome to the second video in this series, Newton's second law of motion, otherwise known as the law of acceleration, and its crucial role in aviation. In this video, we'll delve into the relationship between force, mass, and acceleration, and how these principles govern the flight of aircraft. Newton's second law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. In simpler terms, force is equal to mass times acceleration. Applying Newton's second law to aviation reveals its critical influence on the key components of flight: lift, drag, and thrust. In the context of flight, Newton's second law directly relates force to the acceleration of an aircraft, as expressed by the equation F is equal to ma. Consider thrust, the force generated by aircraft engines. According to Newton's second law, the acceleration of an aircraft, A, is directly proportional to the net force F acting on it, and inversely proportional to its mass, m. Therefore, increasing thrust F results in a proportional increase in acceleration A, given a constant mass of m. Similarly, lift, the force generated by wings to counteract gravity and keep the aircraft airborne, is subject to Newton's second law. The lift force, F, is directly proportional to the force applied to the wings, and thus to the acceleration of aircraft A. This relationship ensures that as lift increases, acceleration also increases. Conversely, drag, the resistance encountered by the aircraft as it moves through the air, opposes the forward motion. Newton's second law dictates that the acceleration of an aircraft, A, is inversely proportional to its mass, m, and directly proportional to the net force acting on it, F. Therefore, reducing drag, F, or mass, m, results in an increase in acceleration. In summary, Newton's second law governs the interaction of forces in aviation, as expressed by the equation F is equal to ma. Lift and thrust act directly proportional to the force and acceleration, while drag and mass affect acceleration inversely. This understanding enables engineers to design efficient aircraft and pilots to navigate safely through the skies. Let's consider a ball with a certain mass m and an acceleration a. According to Newton's second law, the force acting on the ball is equal to the product of its mass and acceleration. When the ball is pushed or thrown with a certain force, it accelerates in the direction of that force. The greater the force applied, the greater the acceleration of the ball, as long as its mass remains constant. In the real world, Newton's second law is at work every time an aircraft takes off, climbs, descends, or lands. By applying these principles, pilots can precisely control the aircraft's motion and maneuverability, ensuring safe and efficient flights. In conclusion, Newton's second law of motion provides a framework for understanding the forces that govern aviation. By grasping the relationship between force, mass, and acceleration, we gain insights to complexities of flight dynamics. In our next video, we'll delve into Newton's third law of motion, exploring how every action in aviation has an equal and opposite reaction. Stay tuned for a deeper dive into the principles shaping the skies above us. If you found this video helpful, make sure you like and subscribe, as it really helps. Thank you.